Um, how did we get here? Where did we start? Why was the Jackal protocol even started?
Yeah, it's a good question, right? So we started back in before 2021 when we started Jackal. We were working in digital forensics and investigations, right? And we found this common flaw when we were doing investigations that there were really no SaaS applications, so like software cloud-based applications where we could like have forensics tools. Reason being, right? You have the situation where you need like track and trace and chain of custody of digital evidence before courts. And when you're doing that, there's no real way in a cloud environment to track and trace digital files where it's completely in a clean forensic environment, right? So what we thought was like, okay, like I guess like we were doing a lot of work on like blockchain investigations and flash loan attacks, trying to get people's money back. And we're like, this technology would be pretty cool if we used it as like a chain of custody tool. So who has what files before the courts that are in like a clean forensic environment? So we thought that was great, and we built this little thing called Keepsake. You might be able to cut to it, where it's Marston's OG evidence capture platform that we were trying to build as a SaaS. But for us to deliver that, we needed a place in the cloud where only the end user could access it, has full chain of custody, so who had access to what files at what time, completely private, so no one can see the evidence, and to even provide that service, right? So we were just like, okay, I guess like we should go and look at like a Filecoin or an Arweave and all these decentralized storage platforms. But we realized all of the ownership and all of like the permissions and all of like the applications of Web3 that we love, where you own things and all that good stuff, that wasn't built into those platforms. So we couldn't really build what we wanted to build. So we're just like, okay, I guess we're building a cloud storage network with that's ridiculously secure and on-chain permissions and self-custodial and all that good stuff. But Marston, what was it like trying to, what was it like trying to explore, like what were the different options?
Wait, hold on a second. Before we get into that, tell me more about this digital forensics life. Like, what is like the day-to-day? Like, what are we actually like doing before we get to this particular protocol? I've watched CSI, so I know a lot about,
It's like that, but in front of like at a desk.
Yeah, and
way more boring.
Really boring, and not nearly as fun as this industry. This industry is a blast, but it's a lot of just like dealing with lawyers and trying to like capture like digital footprints and try to figure out like what someone's been doing online and stuff like that.
Wait, but what is a digital footprint? What are you guys actually doing? Somebody hires a digital forensics entity. I feel like a lot of people don't know about digital forensics.
There's all kinds of different verticals. Like there's like the OSINT guys, which what we were doing, so it's open source intelligence, and then there's the guys that are like cracking open phones and imaging RAM and stuff like that. And there's all kinds of like different verticals in the space. But what we did, we were primarily working on like the OSINT capture side of things, where we were like capturing open source obtainable information on the internet, and then turning that into evidence, and then building packages, and then delivering that to the lawyers, right? So it was a lot of sitting in front of desks and
browsing Facebook,
and then there's all these tools, right? And this is something that's really interesting in like traditional Web 2 is like you could take a username or an email, and you could take that data point, and then you could turn it into like 15 different data points. Right. So I can be like, okay, like what are all the data breaches that have happened? And those are all publicly open source attainable information, because a hacker would break into something and then release it online, and people would buy it for a bit. And then eventually it just becomes like in the open internet. And that's kind of like the same. Those databases are the same thing that your iPhone will tell you is like, hey, like this like password has been seen in like XYZ amount of data breaches. You should probably change it. Right. So like those same databases we would be using to essentially take that email, figure out if it's associated with like a phone number or an address or anything like that, and then use those data points and rerun them until you can build an entire profile on someone.
But like getting down to like, okay, who's like hiring you? Like who's hiring a digital forensics team? Like, did you guys work for like the government? For
no,
like
a lot of civil
law stuff, a lot of criminal law stuff too. So sometimes we'd be on the defense side.
Lots of fraud.
Sometimes we would be in the civil stuff where like no one like it's just like two parties.
Like, is it like my wife's cheating on me? I think.
Yeah, not really as much that stuff. It's more like let's say that for example, like you have a CEO that for some reason like his like all this money leaves the company and you don't really know why, and the investors are wondering what's going on here, and like like, why do you do it? And they say they're being extorted or something like that. And then they buy Bitcoin. And that's how we kind of got into like the whole crypto side of things, where like people were using blockchain rails essentially as like a way that they thought was like really sneaky. And it's actually like really the worst thing that you could possibly, the actual like worst possible thing you can use for money laundering. But like also other things where like that kind of leads us in. So a lot of civil law, a lot of criminal law, a lot of like internal investigations for companies. And we were just kind of like working all that kind of stuff. So it's primarily like the client would hire the lawyers would hire us. And we got into crypto and blockchain based on this, right? So we worked on like flash loan attacks, where like people were hitting decentralized exchanges and liquidity pools with flash loans, and then like unbalancing the pool, taking all the money. And then they would be in the situation where like now they have all this crypto. This is like 2021. So like it was worth of like some kids, like some like guys were like 18 years old, like that would just do these attacks, get $15 million out and then try to run away.
Wait, so, like who's contacting you on behalf of the decentralized exchange to like go after people?
Yeah,
is it just like a member of the DAO that's like, hello,
sometimes,
been attacked.
Sometimes it was the member of the DAO. Sometimes it was the exchanges themselves. The big issue was back in 2021, you'd have like someone that would like steal like money or crypto. And then the recourse is like, you'd be like, okay, hey, Mr. Police Officer, someone stole my crypto coins and like, can you help? And they'd be like, I don't know what you're talking about.
I don't even know what this item is.
So then they were just like, okay, I guess like, or even if the police took the case, then they would go to the lawyers. And then like, or they would go to like the, in Canada, we have something called like the Crown, where the Crown attorneys and crowd prosecutors. And like they would be like that would be like the police would work with them to build the case, and they would be like, we can't argue this because we don't understand this.
They didn't even know what web browsers were.
No, like like you go to court with like, it's like, okay, like the individual used a web browser, and the judge would be like, what's a web browser kind of thing. Oh, no. So like it was bad. Oh, no. So it was a lot of recovery back then in 2021 was civil. We're starting to see a little bit more criminal. You see with a lot of like SBF and like some like the big high profile cases, they're going criminal now because like they're starting to slowly get there, but it's still a lot of the recourse was civil when we were working in it.
Take me on like a little bit. Is there like a specific like case that you probably can't talk about? Seems like an NDA thing, but like I hire you. I'm like, my Dex got hacked and some asshole took all the money. Yeah. Like, what do I do? Am I just like, here's the transaction that it got hit with? And like, what do you guys do next? Like, what's like the next like step in like a process like that?
You start with like, you just get as many data points that you can, right? Mm-hmm. So like, let's say like you say, hey, my Dex got hacked and I have like this wallet address that hit it. And then you can start there and you can try to figure out like, okay, what exchanges are they interacting with, right? And then you can go down that way. So you try to like work your way back to a choke point where you can nail them. But like, it really depends. Sometimes we had a lot of information. For some reason in Web3, like if you're like hacking something, for some reason, like you have this inability to stay off of Twitter and brag about it. So like that was really helpful. Where people would just like brag, like it was just like they would hit the exchange and then they would just like celebrate in the Discord. Like,
and they'd be following like 10 accounts. So you'd look at those 10 accounts and then you'd be like, oh, that's their personal there.
They always return to the scene of the crime. Wait, they would be bragging about the hack and they would be following their own account.
Sometimes like just like they'd leak data points that way.
Or they'd be in the Discord and they'd have a username in the Discord, and we'll also find that like the person had like the same username on like Roblox or something.
Yeah.
So,
really?
Like,
so you guys are just like combing through everything.
Yeah.
Like social sites.
And then everything
websites.
You do, right? Like every time you see their account on Facebook or like a crypto transaction, whatever you look at, every single page you visit, you have to like download a full copy of it because you need proof that you went down. What do you mean?
What do you mean download a full copy? Yeah. Am I just screenshotting it?
That's why we made Keepsake, right? Yeah. So basically, like you're browsing the internet, so you could build these like plugins for Chrome or like Firefox or something like that. So while you're browsing and like doing like the entire case, this Chrome extension is just like taking that entire website in like PDF and HTML format.
And so then download like every image, every piece of text, every link, all of that.
So you're like screenshotting it and downloading like the code for this particular page.
It's not only just like chain of custody of like the evidence of like who touched the evidence. It's like, how did you get to the evidence? So like the entire time you're browsing the web and like the OSINT side of things, we're in a situation where we're just like downloading like web pages, like we're just like the Internet Archive for our own investigation, right? Got really crazy.
Yeah.
But you couldn't do that in a cloud environment, so you couldn't have cloud forensics apps like that.
Yeah.
Which was an issue because like
you don't want Google seeing everything.
Hard drives on a hard drive stacking up on your desk because like as the longer that you work on a case, like the more data that you're storing.
So I guess to put it in like a physical evidence term, because once again, I've seen a lot of CSI, I've watched Dexter, like bullshit like that. You're going to all these sites.
Yeah.
You're seeing the evidence.
Yeah.
You're picking it up. You're putting it in the evidence baggie. And you're like taking it back to the evidence locker.
Yeah.
It's at like but you're doing this all in like a digital environment. And just the types of like evidence that you're getting are just like what? Like websites, photos, like what kind of stuff?
Images, pretty much any like thing that you can find, specifically like in OSINT, right? It's anything you can find online. So PDF documents, if they're like, they have a personal website, you're downloading that website, you're downloading all their social medias, and like then you're also downloading every page that you hit in between those points.
You're downloading like accounts, like the full thing.
Yeah.
So they can see the full thing, and then there's probably like an individual
like every Facebook post they've ever made.
Whoa. And then what do? Do you put it up on one of those detective boards with like the yarn and you connect
digital
the
one
pages?
maybe. Yeah, digital one maybe. But like I don't know, like when you see something like that was important, and then like you would like
you flag it, you put a note,
be like, okay, like this is crazy, and then you put a note on it, and then like you have like your hashes and all that good stuff. But it fundamentally like sucked from like a software side of things. Like it was just like the software was like they were good for what they could be, but like the limitations of like you couldn't put the evidence like in a cloud environment because like inherently like a Google or an Amazon or a Microsoft has a backdoor into that information. So that like then you would in theory have this argument that like, well, like the defense lawyer would be like, well, sir, actually like how do you know like it didn't get tampered with, or how do you know like that's an employee at one of these companies like had access to that the entire time? Like, is this a clean forensic environment? The answer to that is like by physics, no.
Yeah.
Right. So we would have to then we're just like, okay, like this is like extremely unscalable.
Yeah.
You can't like, you were just like collecting all this information. We're storing them on these drives. And like, is it possible to like make this cleaner and make it better and like use a blockchain to track who had access to what files?
Were you guys even able to store it on like a local like server at like the digital forensics office? I have
because
no idea.
Multiple cases couldn't be on the same drive.
What?
Yeah.
Why not?
Because you have cross-contamination of all your...
Yeah, so you'd have desk just covered in hard drives.
Whoa.
Yeah.
Would you guys, and like, what, and you just have to manually back that up and stuff?
Even if you're like doing the investigation, you would have to have like every investigation had to have its own virtual machine.
Yeah, you're booting up a VM for every time.
Yeah, so because like if it had
clean slate,
if there's a like if you're using the same like computer without like doing it in a virtual machine environment, like you have like this cross contamination. Are there viruses on your computer? Are there like all these? So it's like really hardcore when it comes to like the cleanliness that you need. So we're just like, okay, like we can like thinking from first principles, such a VC term, first principles. But thinking like from first principles, like, is it possible to create these clean forensic environments with like crypto wallets, basically, right? So your private key, you can have like a new wallet for each case. And could you essentially build this capture product, right? So we built the capture product, but we're like, okay, like where are we going to store the data? And like,
because I guess there's two things: you gather the evidence, and then the evidence has to go somewhere in one container. And then like, what happens when I show up at court to present the evidence? Well, I feel like that's the other half of it, right?
Oh, that's crazy.
That was the craziest part, because like you would show up to court and then like the lawyers would be like, okay, and the metadata for this file. And it's just like the file was created yesterday, because you have not only the analysts, which were us, and like the forensics guys, and then you have the lawyers, and then you have the other opposing legal team.
And they both need access to the same data.
And we're sending it back and forth. So we're sending files to them, and then they're sending files to them. And then like there's files that are being submitted to court. Like it was just like a nightmare of like who had access to what files at what time. And if like we were seeing situations that were like really bad, and like evidence was just getting thrown out of court because like someone like takes a screenshot and comes to court with a screenshot. It's like,
what's that?
What does that mean?
You can Photoshop that in 3
like,
seconds.
I could like you like even with these videos, like you can edit out whatever you want, right?
Yeah.
So it's pretty interesting situation, and yeah, that's kind of what led us into like blockchain for chain of custody of it. And
we'd hash all the files and then post a timestamp on chain.
So
interesting.
we're doing it just for that portion, just like for like the application side of things. So it's just like an app. We built it on Polygon.
Yep.
And then like it was good and like it was working. And then we're just like, wait a second, like where are we going to put the files?
Yeah, because we started looking at like legislation around how we need to like handle those files. Because like it's awesome that you can prove that file was the original file you're talking about.
Mm-hmm.
But now, you know, if we're putting it on Google Cloud or Amazon, they can see it. And like that breaks all kinds of regulations around how you handle data. So trying to create a clean forensic environment that nobody has access to, even if you can prove that data is the same data that you put in there, it's still like they can't touch it. They can't see it. And it becomes this whole extra layer.
Do both sides get access to the data? Sure, because the defendants need to be able to access it and build their own case against
discovery.
it. Yeah, interesting. So like when you do discovery like the old way, when you guys like first started, usually like, are you showing up to a physical courtroom with like a hard drive and like plugging it in and
like sometimes like there's like e-discovery platforms as well and like some stuff, but predominantly like there would be copies of the evidence that are being shared around, and then the core like captured evidence would be like sitting on the hard drive, and like sometimes they would ask that like we give them the hard drive and they give it to their guys.
That sounds dicey.
Who are like trying to throw out our stuff, like, right? So it was it's an interesting situation, but like this isn't just the case for forensics, right? Like you look at a lot of the healthcare system because like their compliance rules, like the more compliance rules you layer on, like usually the worse the software is.
Sure.
And
100%.
right. But like, is it possible for us to like kind of like hit parity with cloud while still maintaining like the security and privacy posture that you need? Was like kind of like the issue that we were looking at. Like you look at healthcare, all their systems are old. Like there's servers in the basement of the hospital. Like the data is not very accessible. Like you can't like really like use other applications because of all the rules. So like having like one thing was like the capturing of the evidence. But while we were starting to build this thing, we had to start to move down the stack because like, tell me about like your experience, like looking at like a Filecoin or looking like at an Arweave or a Sia. Because we were just like, we didn't want to build this.
And before we go full like Web3, one thing I think is like super interesting about just like you guys in this particular project is I feel like there's so many other like Web3 projects that are just solving Web3 problems, and they seem like they're just in Web3 for the sake of being in Web3.
For sure,
and like they're not really like I feel like you guys originated with like an actual problem, like a real life like situation, and also you guys are already like hashing data to like prove that that's the original file. So I feel like we're getting close to like the crypto realm.
We were really like, we're not in blockchain because we love blockchain, although we do.
I love like throwing some longs on Hyperliquid. Don't get me wrong.
But the reason that we are doing what we're doing is not because we looked at blockchain as this emerging technology and we're like, I got to get in on that, right?
Yeah.
We looked at our problem and said, what can we do to solve this problem most effectively? And we kind of worked our way to blockchain, which is something that I guess you don't really
see every day.
Very often
usually,
anymore.
like you're in blockchain, you're just like, okay, like how do I like morph this by physics?
How do I put movies on blockchain?
Yeah.
Well, I feel like it was just like such an organic like build up because you're obviously like hashing files and time stamping files to like prove that they're the original file type, and then also at some point someone hit you up and said that some Bitcoin was stolen, and you probably just had to like brute force, dive right in, learn every single thing from the ground up,
and then we had to argue it
to the lawyer.
We had to argue it, like, right. So we had to like very quick, because at that point, like we were getting so much business from being like the crypto guys, because like one lawyer would use us, and like these kids figured it out basically, and then they go, okay, like these are like the guys in Canada for kind of getting like recovery, and like so we. At that point, there were no experts because like it was only it was 2021, right? Like it was pretty early. It's like the tokens before that weren't really valuable, like, right?
Yeah.
So like there's just like, oh, like I lost like a few like $1,000. Like the cost of you getting recovery for that was just like the lawyers are going to be more expensive than the amount of money that you lost.
But now you're losing millions.
Yeah.
And that's where
like, once we
change.
start losing like millions, they started. Like one lawyer said like, hey, could you guys figure this out? And we figured it out, and we're just okay. We got like a very deep understanding of how the technology works. And then you go down the road of just like now every lawyer in Canada was calling us for civil recovery of digital assets because we were like the guys in Canada, I guess, for this activity.
And that's just going to continue to get bigger as Web3 gets bigger.
Oh my gosh,
absolutely.
Stuff.
I mean, even in Canada, people are like constantly developing tools to make just tracing where crypto goes way easier. Like I know there's those like
there's chain analysis and there's like a blockchain intelligence group.
Yeah.
And,
so you guys are like coming through Bitcoin transactions, like stolen funds. I'm using Bitcoin just as an example here.
Bitcoin's a pain in the ass to track.
It sucks way more than Ethereum.
Really? Yeah. Interesting. But then like at some point you have to gather all these evidence points and then you have to explain to a lawyer who doesn't know any of this.
Yeah.
And like, I don't know, isn't familiar with any of the technology. You have to like build from the ground up. Like I feel like you just have to know the product inside and out.
Yeah, you really have to know what you're talking about in order to argue it for sure.
Because they're gonna throw everything in the kitchen sink at you to try to make you screw up and be like, oh, like you actually don't know what you're talking about. Yeah, it's just like it's just kind of one of those things, right? Where like it's early technology, but like once we started building this product, like we just loved like building products, right? It's just like we were like working in services, right? Like we get hourly kind of situation where like, oh, like a case and like we're incentivized for the case to go as long as possible so that like we get paid more.
that seems like
it's the same thing as lawyers. It's like we're just like our billing structure is the same as like the lawyer billing structure, and it was just like it wasn't fun. You know, and like I like once we started like building that platform, we started to love like building applications.
Yeah, Keepsake was like the first foray into like having something tangible that we could like show to other people and get feedback on, and that like iteration process was just so much better.
Like I loved it.
Well, let's talk a little bit about Keepsake. So you guys are seeing this whole issue of we need like a no man's land, a neutral place where we can store evidence, where both the defendant and the opposition can access that evidence. They can be certain that these files are like the files, and we can like track that like in a completely like neutral way. No backdoors, no like eliminate all possible variables. That's like the issue, right? That's like the thing we're trying to solve. So what is Keepsake? Like what exactly is that particular product?
Marcin, like talk us through like what Keepsake is.
I have it here.
Yeah.
On the screen.
It's basically what we did is we created this application that was kind of like a web-based application like most things are now. And it was essentially just a way like you could upload files, or we had a Chrome extension that would let you basically just you click it and it would just capture your page, and same thing, it would run in the background as well and capture every single page that you would make. But instead of just capturing the evidence straight up, it would add it to your case structure, and then it would take that entire file, whatever you're uploading or capturing, and it would hash the entire file. And that hash of, like if you don't know what a hash is, it's like a one-way algorithm. So I can prove if I have the hash that this file belongs to that hash. But if I have the hash, I don't know what the contents of the file are unless I have the file sitting with me and I can use it to like cross-reference, right?
Got it.
So what that let us do is it let us put just the hash on the blockchain, which is public. And so nobody would know that, you know, I'm uploading a scan of some dude's Facebook to the blockchain because I'm only uploading the hash. But if I have the scan of his Facebook, I can say, look, this transaction on the blockchain corresponds to this guy's Facebook page. And that was what we initially started with. That was like the core principle of it, which let us keep that chain of custody. And if I sent a file to somebody else, it would then show on the blockchain, this file moves to a different wallet. And so everyone on the platform would have a wallet that was set up through the platform itself. The platform kind of managed the wallets for you, which is something else that we kind of ran into later is having custody of the wallets themselves.
So Keepsake is just keeping track of the hashes of this.
That's all it did. It all just like you captured evidence and they proved the chain of custody of it.
And if someone fucks with the evidence, the hash is all fucked up, and we know that this can be thrown away.
But the other thing is like when like our other tools, like we kind of knew it was like a fugazi because like when you were hashing things and like not putting it on chain and like proving that you could just like change the file there, then hash it and then
change the hash in the document. So you could edit everything.
What?
Like the old system, right? It would hash your file. It would say, here's my file. This is the hash of the file. But we'd hand them. You all right over there?
We'll cut this part out.
I'm just dying right now. Just dying.
So we would take the file, we'd hash it, and then we'd create a PDF report. Mm-hmm. And in that report would be a screenshot of the file and the hash of the file. And then you'd have your drive that you could match them all to. The thing is, right?
That sounds like a pain in the ass.
If I go in and I change that file in my drive and then change the screenshot in the PDF and then change the hash in the PDF, there's no chain of custody on that PDF itself. So I could just go in and rehash the file.
Because you're still there was still trust on the analyst. Right? That like we weren't like screwing with like the files and the hashes themselves. So like the thing is like unless you're like putting it on chain in real time as you capture it, it's kind of bullshit.
It's kind of all useless.
So if I have like a JPEG that I'm using for some evidence, like the system would hash it, it would put it on the PDF, it would have the hash there. So the opposing team knows that JPEG is the one that goes with that hash, but I could just Photoshop it and then just make a new hash and just put the hash on the JPEG. Yeah. So this like PDF that's being presented, that's like the centralized point of failure in this whole kind of operation.
Essentially.
So we tried to change that into a blockchain system.
Got it. So this is like the real like Jackal point, like being like born, like where we're like we're just gonna store the file and not just the hash.
Well, we were gonna store just the hash on chain because you can't store a file on chain.
Sure.
Like the ordinals, like what ordinals are is like you're taking a file, but like you can't really do that big of a file.
Yeah, there's a pretty small like file size limit on ordinals.
And then on top of that, like with the ordinals, you'll notice like when ordinal
what is an ordinal? I'm dumb.
It's just like a file in the block.
Yeah, it started on Bitcoin. It was like a way for Bitcoin to do NFTs, kind of.
They're like transcribing it on chain. No?
Yeah, they're just like embedding an image into a transaction.
It's just like there was like transcriptions and ordinals, like they called it. They called it all kinds of different names. But the thing is, like, remember when like the ordinal theme, like it was like last summer, I guess, is when it was starting to take off. Like all the chains just started going down because like people are just like hammering the chains with JPEGs and the validators were like,
what do I do with this huge file?
Yeah, like a lot of chains were like slowing or like kind of like halting, which was like a huge issue. So it was kind of interesting.
The blocks just got too big.
They got
like
so
on
big.
Bitcoin, for instance, like how big of like an ordinal am I able to store?
I think it was like 1 megabyte max, because it was whatever would fit in the memo field of your transaction. Basically, you like embed it in that way.
Weird.
Yeah,
so it's kind of a hack. Like Bitcoin's not meant to do that.
Not at all. And the gas cost was huge.
So much.
Like it would cost a lot.
Like,
of Bitcoin.
Like there's like some guys that are just doing like $1 million like to just like make like a project on Bitcoin, which is insanity. It's funny.
So we can't actually store the actual files. The ordinal can only store 1 megabyte of files. Yeah. So that's not like too helpful when we're dealing with like a shit ton of stuff.
Yeah, you could have a web page that has so many images on there that already you're like looking at like 300 megs just for like a basic Facebook page.
So we need a blockchain environment. We need a self-custodial no man's land where we can store it as much as we want. Hopefully.
It led into like what we needed on chain and what we needed off chain was just like on chain we needed permissions. Mm-hmm. Like for this thing to work, like we had like a laundry list of just like the must-haves, right?
Yeah.
So we needed permissions, we needed like metadata, and we needed like file structure, like file trees and like
just like an organizational structure.
And then was there anything else that we needed that would like needed to be on chain?
Not really.
Not everything else that we added later was just for fun, but like those were like the things like names like random shit. But like that was like we needed that for us to build that. Yeah. Right. So we needed these things for Keepsake. So we're just like, okay, like blockchain's ownership and decentralization and like all this stuff and like that we were preaching. And we're like, okay, like let's go and grab like we didn't want to build the storage network back then. So we're just we're just like, okay, like let's check out Filecoin, and like you can go down the list of like what it was like to like look at the different options that we have in the market, right?
So we have Keepsake that's just doing the hashes. So now we're looking for a place to store the file.
Where's the file going to go,
gonna
right? Because Keepsake would work like if you did it locally, but like
it also worked with
scale.
Google Cloud at some point we had, but then we were like, that's a test environment for sure.
Yeah. So we're looking for a storage provider for Keepsake at this particular point. Who are the contenders and why didn't we like them?
So there were four main providers that we were kind of looking at. First and foremost, Filecoin. They were the oldest. They were the classic. The biggest by far. Filecoin, because they were the first, they did a lot of things that nobody else did. The problem is they did a lot of things that nobody else did, right? So they weren't anything like a Web 2 platform. They were a marketplace model. They had a lot of very technical requirements to make sure that your files stayed up. And the way that they did their proving system, very efficient, but it made it so that the individual files themselves were like bundled and repackaged into a completely different format, which made it very, very hard to deal with that data, right?
Sure.
So what you ended up doing was you needed a node to connect to the blockchain.
Mm-hmm.
What you would then have to do is you would have to take your file, upload the entire file onto your node, and your node was expensive because it had it
was like $25K or something like that.
Yeah, it had a lot of
what
to spin up a Filecoin node to use it.
Even to rent one was like $300 a month, I think.
Whoa!
And because the hardware requirements on those were pretty robust because of the hashing structure that they used.
It's like the way that like those like I feel like they're kind of like the first generation storage chains.
They were proof of work.
They're proof of work, and then they needed to do storage. So like the actual like machine was both like the miner and the storage provider.
It's doing a lot. It's
and
doing
like you're like optimizing for both, and like it kind of had drawbacks too, right? Because like you were looking at like the speed that we could get the files back. Because like they're doing so much work trying to like do the proof of work,
and
plus
that's
they're
why
trying to serve the files.
Had such an efficient proving mechanism where you basically needed to convert your file to a different format. And so you would upload your file to the node would then process it into a different file, and then you'd get details about the file, which then you'd say, hey, Mr. Node, I want a file deal. And so you'd say, I want this provider to store my file for this long and at this price. And it was all a marketplace. So today your file could be stored for $10. Or it could be stored for 100 or 10 cents, and you wouldn't really know until you went to store that file, which
could be
like dynamic marketplace pricing. Plus, we didn't have encryption or privacy or like file management. So
we had to do a lot on our side. Like we had to rent that node, and then we had to have a server running to manage the file deal. So like if my file deal expired, I would need to renew it, and managing the renewal was something that we had to do as well.
Like manually, you'd manually like
you could write like a program to do it for you, but then we needed to run that program somewhere.
But also like it just like purely just like the biggest blocker for that was it wasn't fast enough to have a cloud app.
Yeah.
Like, right. Cause it was taking 24 hours to get the files back sometimes. Like
that processing system, because they had it set up in that way, they had the nodes that would run the machines, and then they have a retrieval marketplace. And so the retrieval, you'd have to pay every time you wanted your file back.
A degress
because they would
fee.
need to pull the file off multiple machines because they would split it and do all that processing and then put it back together for you and then hand it to you. And that process would cost money, and it would take up to 24 hours before you could say, hey, they never sent it to me. I want my money back.
From a business standpoint, this is a no because, if I get everything lined up one month and then the price jacks up the next month, I can be hosed.
They're good for one thing, like, and they do it really well. It's like archiving, right? Like putting files away to rest. You don't need to add, but like you need it, but you don't need it right now.
Deep storage.
Yeah, you need to know it's there, but you don't need to access it.
Well, it's a big industry though as well, right? Like there's a ton of data use cases in which that model is awesome. It's honestly ideal for like a backup, for example. If I'm backing up all of my systems, if I'm a Web 2, Web 3 business and all I'm trying to do is store the information, I don't need to access it. I don't need to do anything with it. I just need to know that it's there.
Yeah, you hope you never have to.
Right. Best case scenario, I never have to touch it.
I'm fine with not accessing it for 24 hours
if you don't need it for 24 hours, awesome.
And they're phenomenal at that. But there are also a ton of use cases in which 24 hours is too long to wait.
Like any web scale application, like you can't like use that for like the environment to build an app like this, for example, right? Which kind of leads into Arweave.
Yeah.
Let's talk about Arweave. Competitor number 2, or option number 2.
Is it Arweave or Arweave?
It's Arweave.
I call it Arweave.
I don't know. It's Arweave.
Arweave. Yeah. They are forever storage. So their whole model is centered around you send a file up to the Arweave network. They give you their Arweave identifier, and that file you pay once, it's there forever. That's the claim.
That's cool.
That's cool.
Yeah, it's a really cool idea. The problem with that is in practice, it's a little iffier, right? When you upload something to Arweave, it goes up there. And it goes onto the machines. There's been a hard track record of making sure those files stay there forever. They base all of their economics around like how long they estimate a hard drive to last. And hard drives sometimes just die.
Oh,
and they have no real protections in place to make that happen, like to fix when those problems arise. And so sometimes you just kind of lose your file. So then there's a lot of overhead where you need to upload your file like multiple times. And if one goes down, then you need to manually, or, with a program, but you'd have to write it, go and fix that. And then, the biggest problem of all is if you need a file up there for like a year, you're paying to keep a file up there for life.
200 years, yeah.
Oh, so like there's no, I can't say 10 years.
No, it's up there, and once it's up there, it's up there. So each
file is expensive.
Super expensive.
Yeah, you're looking at like we'd have to pull it up. Maybe like in post we can like put up like how much it costs for like a terabyte or like a gig. But like I think it's in like the tens of thousands or thousands of dollars for a terabyte.
Yeah,
Whoa.
I think it's like $20 to upload a gigabyte right now.
Yeah.
And so if we're uploading a page that's a third of that, and it might be kind of a garbage piece of evidence, right? Like we might not even really
need it
for very long.
No, you don't want to delete it.
And that's the thing. But now it's up there forever, and it cost us like
upfront money,
like $7 to upload that. And that was very, very difficult from a business standpoint. Technically, we could have made it work.
Yeah, same thing, right? Like, and I know Jado's. Like, what do you think? Like about like their use case? Like, what are they awesome for in your point of view? Because I know you deal
file storage is a multi-billion-dollar industry, and it's only growing. So the way that I look at Filecoin, the way that I look at Arweave, the way that I look at all of these guys is, first of all, Filecoin and Arweave specifically are titans of industry, realistically. In terms of Web3 storage, when you think of Web3 storage, let's pay them their dues, right? You think of Filecoin, you think of Arweave. So we've identified that Filecoin is phenomenal for iceberg storage, an archive, for example, that I don't need to necessarily get back in a reasonable amount of time. I can wait. The way that I look at Arweave is the exact same way. There is a great use case for Arweave.
If we're planning on keeping it forever, that's awesome. Like,
NFT projects
Some of the world's most important information shouldn't have a clock on how long it's stored. So when I look at cutting this massive pie that is the data storage market that's only getting bigger, I see a lot of opportunity, because you could look at Filecoin, you could look at Arweave, we could continue to go down the line. And they do their niche super well. The best. The only thing that I would say that we have in common with a Filecoin and with an Arweave is the fact that we both do storage. That's about it, right? And at that point, the conversation changes and it's completely different. And of course, we're going to get into this, but our niche that we're attempting to carve out in the storage market has very little to do with what Filecoin and what Arweave are doing currently.
Because like if you wanted to do 200 years on Jackal, it's going to be more expensive than Arweave, because like we're doing a hot storage active cloud environment. Just like inherently, just based on like the requirements of our storage providers and like the unit economics of our protocol, it needs to be more expensive because like you're doing a different job.
Yeah, our economic system is completely different.
It's completely different than both of them, right? Because like it's optimized for the job that we do. Like we do like hot storage, active cloud, build an app on this thing, like that's like kind of what we're focusing on, is like for an application like that to be fast enough and responsive enough that you can build like a SaaS application on top of these rails. If that makes sense.
So we got Filecoin. It sounds like it's just a little slow, a little too cold for our needs. I don't have time to 24 hours to get back my file. You know what I mean? That's what nobody got time for that. And then it also just sounds like Arweave seems good. we just don't need to store every file for 200
And we don't want to pay
years.
up front for it.
No, it's just too expensive for like real world like use cases and stuff. Who's number 3? Who are some other options?
So number 3, my favorite will be last. Number 3 is Storj.
Storj, yeah.
They were kind of one of the first teams to kind of look at it from a similar stance that we look at it, where they're doing decentralized storage more as like a software as a service rather than like a marketplace model. The problem that we noticed with Storj for our use case was the way that they originally, I don't think they do it much anymore, but they really advertised decentralization. That was like a big part of when we were looking at them, their model. And they had this thing called a satellite system where you would upload your file to Storj themselves, and then they would distribute it out to a decentralized system of nodes, and then they would manage all your redundancy and everything for you. And that was really cool. The problem for us was you're always uploading to them. And if they go down, it might still be stored on those machines, but they are your in and out rail.
Oh.
And so what we noticed, it was a tough call for us because it seemed like a really great solution for what they were doing. And anybody could hop on and be a storage provider and everything, but they would have to kind of hop onto this network governed by a central entity
where they have access to your data, which brings us whole back round to like the same issue with like AWS and Microsoft.
So they were building like a Web 2 type storage SaaS on top of Web 3 tech, but you're only as good as you're only as decentralized as your most centralized component, right? And so being that in and out bridge, anytime we sent them data, they'd see it. And the storage providers themselves might not see it, but we were always trusting storage with our data, which is something we just couldn't do
for like this.
So the actual like storage like protocol, like the actual like storage part, that's cool and decentralized, but the on-off ramp is a centralized.
They were one of the early pioneers, very similar like Filecoin. All of these guys, like they were like the early like DePIN pioneers, where they like Storj kind of went the direction of like they saw that like they could have better margins for like a cloud business, where like you could bootstrap like globally distributed nodes and then have the ability to like aggressively cut prices, because like storage is race to the bottom on pricing just because of like how commoditized and stuff like that. And we can get into like later about like how we want to move beyond storage for us. But that's kind of like they saw that was like, okay, like we can like aggressively cut CapEx and provide a product, but based on like the times that all 3 of these guys built, like blockchains were like they're all still proof of work. Like all 3 of these guys.
I think at Storj's like inception, Tendermint was like just a paper type of thing. Like it was just starting.
So like
Storj sounds like the Uber of. Like,
I know.
Like there's a centralized entity that's controlling. Like they're not actually like buying.
And that was exactly
like that's actually a great comparison. Yeah. That's a really good comparison.
It's the comparison every tech.
Yeah, every tech company is the Uber of.
The Uber of.
But it's kind of like we saw like this market and like they all like. This is kind of what I love about the timing that we had when we entered the marketplace. We were looking at these guys, like they all did the best with the technology that they had at the time. And when you had that technology at the time, you could like only optimize for like a few things.
Sure.
We have like Tendermint consensus. We can like split like the validator and the storage providers, 2 peer-to-peer networks, 2 specialized machines. We had this wonderful, like I almost want to call it like a last mover's advantage, where we can like see what they did, see the markets that they're attacking, not really attack those markets at all, and just hammer on like the hot storage active cloud environment, because we had the ability by physics to actually offer that solution. Like back then they didn't have, like physics would not allow them to like offer something like we're offering today.
Who's number 4? Who was the 4th storage provider that we looked in for?
Number 4 was probably like the biggest inspiration for the Jackal protocol, but it was Siacoin. Siacoin was like the number one thing that I was really into. And we were like this close to using them.
They were still proof of work too though, right?
Yeah. But the systems that they had were a little bit better, because I mean they came after Filecoin and everything. So they saw what Filecoin was doing and kind of said, hey, we can do that better. And their proof of work chain was basically, it was just a Bitcoin fork essentially with like a bunch of extra stuff padded in there. And they had some pretty good optimizations in there to make everything work really smoothly. But they had a very specific target, which was web scale applications. That was like the number one thing that they were trying to do. They had a layer on top called Skynet, which was like a web hosting platform on top of Siacoin. And it was really cool. The thing that we kind of saw with them is the way that they did user management. So when you were uploading files, you had to download a platform on your computer.
Mm-hmm. Oh, interesting.
Instead of using like a browser wallet or something like that. And you would upload your file and you would, go and send it to their network and it would split it into a bunch of pieces. And there was a few things that, because they were a proof of work like Bitcoin fork, they had to kind of do in that user client. So things like redundancy. They split their file into a bunch of pieces, spread it out to the network. And then if those machines would go down, your client would then go and ping them and say, oh man, there's like 30% of the file is lost, but we only need 50% to rebuild it. So what we're going to do is we're going to download it in the background as long as your client's open, take the pieces that went down and redistribute them again. So they had that redundancy, but you had to have your computer on to make that redundancy happen, which was fine for like everyday use, right? Because like how many people are taking their computer offline for weeks at a time?
Especially if you're like a business or something.
Yeah,
you're just
right.
Like letting that thing roll.
So it would just do it in the background. Like you could turn it off and then turn it on the next day. And if it noticed it needed it, it was good. The problem that we were seeing is every single file on there was almost like too hot. And what I mean by that
I didn't think that was possible.
It was too managed by a user account because there was no abstraction at all. And what that meant is whoever uploaded the file could just delete it at any moment with no notice.
Oh.
And what we were looking at is back when we were trying to do Keepsake, the structure we were really aiming for was for our system to upload the file to a platform and take us out of the equation.
Yeah.
That makes sense.
Did Sia have a permission system?
No.
So
they were same thing. Same thing as Filecoin. They were fully public. The thing that they had an encryption system in their client, but it was like only you could decrypt it, and they would encrypt it and decrypt it like as it came in. But they didn't have sharing. They didn't have good access controls on top of it.
That was one of the things that like they were like really really well on the way of like just like if they were able to get rid of the proof of work, like build on top of it. The issue is like when they had like some internal issues where like Skynet and like the Sia Foundation like had like a dispute, and then it just like imploded.
Yeah, and the economics being that it was a proof of work were not flexible. Like you couldn't just put a chain upgrade out and say, "Oh, we're changing the economics today."
Yeah,
like it was very set in stone, strict.
No one wants to pay high gas fees to move files.
No, it's just kind of one of those things, right? But so it kind of brings us back to like, okay, so we saw this market. Like we saw all the possibilities. We realized that like we had like a wish list of a few things that we needed, and like we couldn't get it.
What's on that list?
So
what are the things that we need?
The wish list was number one, we needed permissions and ownership.
Yes.
So who has access to what files? Who owns the files? And is it self-custodial? Can you self-custody files on the network by using encryption? The second thing that we saw, like we needed like it to be resilient in the sense that like if a file goes down or something drops a file, like if a file deal breaks on Filecoin, like you're screwed. If Arweave loses a file, then you're screwed. You have to like upload multiple files, like all this kind of stuff. And for that use case, like we needed like auto healing and a dynamic system to identify it's like that file is gone.
Yeah.
We have to copy from redundancy very quickly and just make sure that we just revive it to like 3x redundancy kind of thing.
Businesses are doing other shit. I don't have to be worried about my files backed up.
It needs to be dynamically healing. So it was privacy, ownership, like a custody system or like a permission system, and then we wanted like file trees. We wanted like some other stuff where it was a little bit easier.
Those were more optional things, but they were quality of life improvements for sure.
And then the big thing was like it needed to self heal, right? Because like you have this distributed network of untrusted parties, and you built this into a system where like the system must take care of all the different possibilities of trust. So if someone screws up, we need the actual blockchain to identify that screw up happened and then rebuild. So that was like the wish list. We couldn't get any of those things. So we were just like, okay, I guess we're building. We're going after it.
Is that a daunting position to be in? Because I feel like you guys just explored a bunch of routes and like possible vendors, and now you're just like,
yeah. I mean, we did spend a bunch of time on it, and then that sucked because we spent a lot of time just researching where to go.
Well, like the journey to Jackal was very interesting in the sense that like we tried everything in our power to
not build Jackal,
and just like focus on like because we just wanted to build like an e-discovery tool and then just sell that, right?
Yeah.
Like we're just like, hell yeah, dude. Like let's go to all the legal conferences and be like, if you don't use this, then you can throw out the evidence and then just like give us all your money. So that was like the original plan, right? But that wasn't working. So we were just like, we actually have to build the thing. And we tried everything we could. We built it on Polygon. Then we were using like Filecoin. That didn't work. Then Polygon and Siacoin. That didn't work. Then we were doing secret network.
Yeah. Initially, our first Jackal prototype, when we were like, yeah, okay, we'll build a cloud, but not like the whole stack.
Yeah, we're not going to build the entire blockchain.
Yeah, we wanted to put pieces together. So our first attempt was we had these nodes that you could spin up, and they would connect to Filecoin and IPFS and the secret network kind of all at the same time. And so we didn't manage any of the proof systems that we do today because Filecoin would take care of that. And then we would host a cached hot version on the nodes through IPFS. And then all of the protocol like access controls and everything were handled through secret network. And then it was just a constant battle of like, okay, well now we need a band-aid to fix the connection through IPFS to Filecoin because the file types are different. And now we need a band-aid to fix the way that we're managing permissions on secret network. And now we need a band-aid to fix that sometimes the nodes would go down. And now we need to prove that they're up. And now we need a band-aid to fix that even though they're up, we need to know that they still have the file. And then it just came fully back around to we need to build a blockchain that manages all of that stuff for us. And like every band-aid that we built was fixing its way to a blockchain, which would have fixed the original problem altogether.
Because you needed to build something end to end like this. Like we needed to control the consensus engine all the way up to like the actual JavaScript libraries for integrating, right? So that was like this crazy situation where like the unit economics started to fall apart when we were using other systems because they weren't built for storage.
Yeah.
They were built for a general purpose, like everyone come build, like whether you're NFTs or things like that. But like those are very like, I don't want to say simple use cases, but like it's kind of like a Snapchat versus like a SpaceX, right? Like you have like these very different situations where like gas prices don't really matter as much when you're like doing NFTs because you only really buy it and sell it every little bit. We were doing like storage proofs on chain. So like we were just like hammering those chains. Like we're filling the blocks.
Any action you took was a secret network transaction.
Oh, we were filling those blocks like a motherfucker.
And and the gas was expensive on secret too.
And then the gas was so expensive and we couldn't control the gas prices either. Right. So like we needed the gas to be cheaper for us to provide the product because we were actually like our blocks are full. Right? Like V4, like it put a band-aid on it a little bit, but like our blocks are like full.
Yeah, and we had to create like a lane system so that regular transactions would use gas and storage proofs, as long as they were valid proofs, would be gasless because otherwise the storage providers would be spending more on gas
than they were making.
So
it was like
and you can't do that. It was secret.
It was a crazy situation. Like not to knock secret. Like secret is awesome for like all kinds of use cases, but like most blockchains aren't optimized for data storage. Like
we were doing
zero of them other
different
than like the L1s were. So it's really important for us. Like, okay, like we need to build from the studs all the way up a chain that's just optimized for one thing. And then we can get into distribution of how we like attack different markets and then like deliver that to all the chains and then give ways for businesses to onboard directly through APIs and just build it for storage and storage only. Let's put it this way, right? Like I would argue that we're probably one of the most custom Cosmos blockchains, if not like the most non-vanilla Cosmos blockchain. Like how many custom modules do we have? Like that are just like built into the chain directly that like we have the storage module,
file tree
module, names, and then is like all the fee grant stuff. Like it's very apparent that we wouldn't be in the position that we are now.
Yeah.
It would be physically impossible to like build that on another chain because we needed to specialize for one thing and one thing only, and we needed to do it extremely well.
I mean, it really sounds like you guys just went down the list as far as like there's the puzzle piece that's the blockchain, there's the puzzle piece that's the storage validator, and I feel like you guys tried to connect so many of them, and none of them quite fit.
Well, and then we went into this like really modular system where we went blockchain with custom modules, validators network, like our validator peer-to-peer that does like a lot of stuff. And then we have the storage peer-to-peer that does a lot of stuff. And like all three of those have to work in harmony, basically. So we had to build this very interesting system that way.
So we're building now both things kind of like from the ground up, and they're going to meet in the middle, and they will be Jackal as one single sexy entity. Where did we start from there? Like, well, it just seems daunting to have to build all this stuff up.
Yeah, it was.
And maybe another way I can kind of spin this is like, how did we end up as a Cosmos layer 1 blockchain?
So yeah, we looked at a lot of stuff. Funny enough, back when we were really diving into kind of putting the pieces together, before we even looked at Secret Network, we were looking at building a Cosmos chain very temporarily.
I was pushing for it early.
Yeah, you were pushing for it. And it was like, that's a lot of work. That's a lot of overhead that I don't know if we need right now. And so we already kind of knew Cosmos, right? And then especially building on Secret, we had our kind of one foot in the door into the Cosmos ecosystem, right? And so we started looking at any platform to build a blockchain on, and we knew like Siacoin built with almost a Bitcoin fork. And we were looking at other platforms like that. We were looking at potentially like a Ethereum fork as well. And we just looked at the overhead of all those things, and it would be like, yeah, we'd be able to do it, in theory. But the amount we would have to customize out would just be so painful that it just wasn't worth our time, especially when we started looking at Cosmos. And it was a little more plug and play, right? Like, they had it set up. It was like them and Avalanche were like the two big ones that made it really easy to build a chain. And we just like the sovereignty and our familiarity with Cosmos over Avalanche. And so we kind of went down the rabbit hole of Cosmos, and this was a while ago. So the developer tooling wasn't stellar. We had a lot of stuff.
Is it today?
It's definitely better. It is definitely better. We started using Ignite to like bootstrap our chain really, really fast. And Ignite does a lot of things really, really well. It does things way better now than it did back then. But we just kept kind of running into hurdles. And then we had to try and launch the chain to discover what some of those hurdles
That's
are.
Where we met Jacob Kadiki for the first time.
Yeah. And there are definitely like artifacts left in the chain that shouldn't be there. But the overhead to update it is just so high that it's not worth us doing anymore because it's set up that way. So it's not like there's certain parts that still exist that are
like
relic
stubs
of
to stuff.
And like even the way that some of our systems are built using numbers, but they're actually like string representations of those numbers instead of raw number values. Yeah. And then we convert them back and forth every time we read them out. So there's a little bit of overhead there. And obviously if we want to go back and fix it.
Had time to go back and fix it. We have a lot of shit going on right now.
It's such like a minor part of the stack that
it's kind of one of those. It's like there's no doubt that the Cosmos SDK is like the best SDK to build blockchains. Like Polygon's built in the Cosmos SDK, I believe, right?
So they're built on Tendermint.
Well, there's a lot of if you want to go Tendermint, we got Polygon, we got BNB chain, like a lot of all the big. If you look
proof
at
of stake,
top 50 tokens or top 50 chains, almost all of like the best ones are Tendermint consensus blockchains.
Yeah, they're either Tendermint or they're rollups on Ethereum, basically.
Yeah, and that's the other thing, right? Is like even if you look at like Celestia. Like they're built on Tendermint. I don't know how much they use the Cosmos SDK, but you also look at things like even Ethermint, right? With the guys over at Evmos built, like that's been forked to oblivion. Like that thing is used by, I think Barachain uses, like they were started by using it.
I think they looked at it and were going to build their own, same thing. They were starting on Cosmos,
but still, it's like the best like toolbox for kind of building these things, in my opinion. I like obviously Cosmos has its own issues, right? Where it's everyone's sovereign, so there's not like an underlying asset where we're all just like cheering on like Solana or Ethereum. But no, I think for all its flaws, I think that I'm really happy that we made the decision to build in these rails.
I think the Cosmos tech stack is by far the best.
But also
the community sometimes, but the tech is there.
But going and like the way that we can do interoperability outside of Cosmos is also really cool, where we can have our chain built on the Cosmos SDK, Tendermint consensus in Cosmos, but we can do distribution outside of Cosmos, like what we're coming out with the Outpost. It's I think like it's pretty cracked. It's a pretty cracked distribution model for us moving forward.
Well, let's okay. So we are making our own L1 Cosmos blockchain. That's handling the blockchain part. I feel like even if you found another blockchain that like worked well, like governance for that chain that doesn't give a shit about storage could steer it, and then the whole system would just like break down at any moment. So it's probably good for us to be on our own layer one storage built. But talk to me now. I feel like we just talked about the pitfalls of some of these other storage providers. Let's talk about our storage network and like what really makes Jackal shine. What are the like specific things that the Jackal protocol storage network has that these other chains don't? Like
the
I can
why
list
you
a
should
couple.
care. The why you should care, baby. Yeah, it's so Jackal is very, very special in a few things, right? Number one, it's hot. So like it is very blazingly fast. We have like clients that are enterprise, even like developers that are building. This stuff is like pretty awesome from that standpoint. It's almost at cloud parity on the speed, which is pretty insane. Cool. That we've even gotten remotely close to that. The other thing is like the ownership and the self-custody and having that capability where you can actually have a cloud environment, but you're the only person that has access to that cloud environment. So you get the scalability of the cloud, but like the security and privacy posture of just self-hosting or having files in your desk. That's a line that I've used a few times, but that's also like very, very special. I think like the ability to share, like our JavaScript like capabilities, like when it comes to like sharing files or integrating or building on top of it. I mean, like, what do you think is like, what's your top three?
Top three? I think redundancy is huge. That's something that we were kind of also looking at.
The auto healing. Yeah.
The auto healing. Like, and that's something we were looking at with like building on another network, not just Secret, but like obviously Secret was the one we were looking at. You can't automate things at the chain level on somebody else's blockchain, right? With us, what we were able to do is directly in the code that the validators run, every block, they have an instruction set that like, every 100 blocks, I think it is right now, it's a chain parameter. They go and they say, let's look at every file we have and see if the redundancy is broken. And they can do that autonomously every set number of blocks. And that's just impossible to do without third-party tooling on any other blockchain network. So that level of like integrating it into our stack was huge. And it's something that nobody else has because of that. And I mean, Siacoin tried, but that was, again, on their third-party tool.
That's another crazy thing. Like we went hard on like the automation into the protocol directly. Like it's like the permission system, the file trees, this auto healing, like the encryption, all that stuff, like managing who has what stuff. Like we went really, really, really intense on like automating everything so that the protocol could just stand alone. And people could just have that tooling to build cool stuff. But like Jaden, from your perspective, we have like you do a lot of outbound where you're talking with teams and you're trying to get people to use it, whether it's outside of Web3 or in Web3. Like, what do you think is like when you go and you talk to them, like what are your like selling points or what are like the value that we provide to them? Like, what do you go for?
So the way that I answer this question forthright is the worst. I'm the worst. And the reason is because I think that there are so many distinguishable traits about Jackal that the value proposition that we bring forward is completely different for everybody. Depending on who we're speaking to, the pitch is completely different. Like the only overlap is the fact that we're talking about the Jackal protocol in both conversations. So Patrick hit on, and Marston hit on a bunch of the features and the benefits that I look at as more of all-encompassing jobs that Jackal allows me to do that maybe other storage providers wouldn't be able to do. And so we could go, the Web3 route and how we do distribution with the Outpost model. Right now, devs don't have a scalable option to access decentralized storage, right? If I'm a developer building an AI ML application on Base and I want to access truly decentralized storage, my options are I either use a centralized API or I leave Base and I build my AI ML application on Filecoin, which makes absolutely no sense. So what these heavy data users and these applications that are needing a lot of storage end up doing is they go, that doesn't work at all. The only option I have is to use an AWS S3 bucket, right? So the value proposition for deploying an Outpost on Base for those developers would be, not only do you not have to leave Base where you decided to build because of technical optimizations that you could make, because of the massive amount of liquidity that's over there, because of how fast the community is growing. I decided to build on Base for a reason. Of course I want to stay there. But now I can actually access scalable, decentralized storage locally with a simple smart contract call. So when I'm talking to Web3 developers outside of the Cosmos ecosystem, if they're using a ton of storage right now, they're using AWS. And so the pitch is decentralizing that layer of the stack, being able to access a storage solution that works like you need it to without having to go through all the hiccups of moving and going to the storage provider.
Yeah.
When I talk to outside of Web3, when we talk to businesses, the decentralization and the ownership part of Jackal, that doesn't matter to them. And if anything, if I'm a business in Web2, I probably want the ability to wring someone's neck if stuff goes wrong, right? To be candid, right? Like if something were to happen and my storage solution doesn't act exactly like I want it to, I don't want the responsibility to be on me. I want to be able to reach out to Patrick and say, hey, you gave me the solution that doesn't work. What the hell is going on?
Yeah.
So the unique selling proposition for a Web 2 user would be more along the lines of having the highest digital privacy and cybersecurity posture possible, which is made available and made possible through our internal detection of loss mechanisms and through our 3 times redundancy that's geo-distributed. Those tech decisions allow us to offer a product to these Web 2 clients in which they can still ring Patrick or my neck, most commonly my neck, if stuff were to go wrong. But at the end of the day, they're saving a ton of money. They've got an increased cybersecurity posture. They're doing things that are better for their users and how their users want to store data. And we're just enabling them to do that. So
it's a good point. It's a really good point, right? Like it's you can't sell it the same to everyone, right? Like everyone cares about different things. So like just to like consolidate everything, like Jaden's talking about, like, okay, like Web3 dev, decentralization. If they like decentralization, they don't have to like decentralization, but if they do, we got that. The other thing is, like, they're building on chain. You want storage to be on chain first, right? Like you want like a storage solution that's built for an on-chain developer, and like we got that too, right? So like that's kind of them, and we deliver it to them on Base, and that's
the functionality
of it, like the permissions and the programmability and all that good stuff. We got that for them on their chain locally through our Outpost model. And then for like the enterprise for the enterprise user, multi-region geo-distributed storage, that's 3DX redundant. That's also like you get to save like a shit ton of money. That's also a pretty good. That's also a pretty good option.
We're also for the first time ever, and this is just because we started listening for it. We've gotten feedback from someone who's in an enterprise environment testing Jackal right now, and he's not boasting about the costs or the
He's boasting about
he's boasting, and he's sending us demo videos
about the speed
of the speed. So what he's noticed is, hey, as these files get downloaded more and more and more, they're cached closer by, which actually speeds up the time it takes for me to download the file. So if I'm downloading a 1.5 GB file, the more popular it gets, the faster we perform, which is a remarkable advantage.
And just to be clear, they're using a product that's actually not released yet. It's called Jackal Quick Connect. So, sorry, no, it's not Jackal. It's Jackal Pin. They're using Jackal Pin right now, and like essentially, like Jackal Pin is also IPFS compatible. So you have like all the functionalities of like the IPFS discovery layer plus Jackal storage layer. And like it's fast.
Wait, hold on a second. I need to reel you guys back in. I know you guys are excited, but you guys know so much that no one knows. You guys are already on the Outpost. You guys are already on all this other stuff. For just a brief second, let's move back, because Jaden was talking a little bit about, like, you need to know your files are safe. You need to know that they're redundant redundant. Filecoin, you have to manually manage redundancy.
Yes.
I don't want to do any of that.
Also, marketplace model for businesses that is
And encryption.
a non-starter.
Yeah, that's also another thing.
Encryption, you have to locally manage your encryption keys too.
Well, let's just talk about our storage from like a little top down. First off, how do we make sure if I upload a file, it's still there? How do we make sure if I upload a file and it's stored with a storage provider and it goes down?
Yeah.
How are we certain that data is safe?
The short answer is that like all the storage providers that are storing the data, they can't see it because it's encrypted. But what they're doing is they're taking an encrypted kilobyte chunk and they're proving it to the validators like, hey, I still have this file. If they don't do that too many times, then the validators go, what's going on over there? like there's no file there and you're not proving it. We can't trust you. So they're going to break that storage deal, issue a new one. A new storage provider grabs that and then downloads from the redundancy. So it's like whack-a-mole storage basically in that sense, right?
Well, here, I don't even know. Tell me about JPOP. This is what I want to know. I want to know about the actual, like, how are we storing this file? How many times are we backing it up?
Yeah. So JPOP is the Jackal proof of persistence and
Algorithm.
Yeah, it's our protocols algorithm to make sure that we keep things stored when we say we're storing them. And essentially what we do is every time you upload a file, you create kind of an object on the blockchain itself, outlining the details of what that file is supposed to look like. So it lists like the file size, it lists who uploaded it, it lists which storage providers are currently holding it and proving it. And then most importantly, we have what's called a Merkle root. And the Merkle root is this piece of a broader structure called a Merkle tree. And that tree is really, really important because it takes the entire file, splits it up into little chunks, and then all of those little chunks are through an algorithm mixed together over and over and over again until we take two chunks, put them together, two chunks, put them together. And then we have a new level of that tree. That same level, same thing. Two chunks, put them together, two chunks, put them together until we reach one point. And what we can do is we can do a little bit of math. And if we have the data from that top point, we can take any of the bottom pieces, which are just the pieces of our file, and we can prove mathematically that that piece is responsible for being part of that broader tree structure. And then we only have to store the top piece once. And so that's the Merkle root. So we put that on chain. So none of the details of the file are ever put on chain because we don't need to. And then the storage providers themselves, because they're holding that whole file, right? They can just take that chunk and send that chunk along with a little bit of extra information to the blockchain itself. And using that Merkle root, the chain is able to verify that that piece came from that particular file object. And that way we do that over and over and over again with different pieces. And the storage providers themselves over time prove that they have the whole file. And we make this kind of assumption that it's economically unviable for them to discard the pieces that won't need proven because they don't know which pieces are coming up next. And the cost that it would take to like move that to an archive system that's cheaper to store it and then pull it back on when they need it is higher than it would take for the loss of failing to prove that deal over and over again.
For those that just listen to that, there's going to be a pop quiz after this. So if you enjoyed that, stay tuned for Ian's pop quiz.
All right, here's let's back this whole thing up. We got to the point where we're like, you know what? We're going to make our own blockchain. We're going to make our own storage network. We're going to make all the files that go up in the storage network private by default, which is something that a lot of these other storage providers don't do. As Jaden was saying a little bit earlier, we're not going to make it a dynamic marketplace model. People aren't bidding on storage. Why did we decide not to make it a dynamic marketplace model? Because I feel like every other Web3 thing is like a dynamic marketplace model for sure.
If you're using storage right now, and like we're going for like $1 billion, $1 trillion scale here for like this to work, it can't be a marketplace model for storage. The reason being is that you need to make informed business decisions, especially if you're storing at scale, that you need to know how much of this is going to cost. And then if the price goes up, I need to know, and then it can happen once a year maximum or something like that, right? So that's the kind of situation that we're in, where people are making business decisions and they have a budget for these things. And if you don't know what the cost of it's going to be, that's a really big issue. So number one, it's familiar. Number two, it's a lot easier to manage by setting a standard and then just having the storage providers just built into that standard, and then having the econ just take care of everything for you. The other thing is that you don't have to manage anything, right? So you can just if you pay for storage, you get storage.
Yeah.
Right. You don't have to go and check every day, are my files still there? Are they not? That's kind of a situation that you don't really want to be in if you're a business that's managing data, especially if it's important data, right? So that's why we built it in the way that it is we can have standardized pricing that's controlled by governance, where all the people that are involved in that governance decision are incentivized equally for the protocol to do well, right? So the storage providers, if the storage providers can't be profitable, then there's no use of running it. And if they can't run their things, then the people that are purchasing the storage, they don't have anything to store. So it aligns incentives around all the participants of the network around that governance decision as well.
Who determines the price of storage on the
protocol? You could literally go to the protocol tomorrow and put up a governance proposal, and then the token holders vote.
Just to kind of double tap on the marketplace model, Pat said something that I almost laughed out loud at, where he said, if a business doesn't know how much they're going to spend on storage, what their budget is, there's a problem. And I would double tap that and say the problem is actually ours. If I'm attempting to pitch a Web2 business on onboarding to Jackal and using Jackal storage, and they go, how much does this cost?
And then we'd be like, I don't know.
And I say, exactly, right? I say it's going to cost you, including all your data, you've got this many terabytes, it's going to be $2,500 a month. Today. Tomorrow, I don't know what the price is going to be.
It could be 10 cents, could be $1 million.
By the time they talk to their team and they get the approval to authorize a $2,500 a month spend, it could be $2,200 a month. It could be $2,750 a month, right? It puts them in a position where they're trying to forecast the unforecastable, which at that point, it becomes my problem.
And that's not just for enterprises either, right? If you're a developer that's building an application and you're building the storage, if you're building a social app, the price of storage has to fit into the unit economics of your business.
Yeah.
Absolutely.
Right? So if I don't have a standardized pricing that I know I'm going to pay, which you can also prepay for on the protocol, you can buy 100 years of storage if you really want to.
Yep.
You bought it. Right? So the protocol, they can't kick you off, right? So that is your price. It's like a prepaid storage card, basically, right? So it's pretty interesting that whether you're a developer or an enterprise or an individual, you need to know how much this thing going to cost for you to make business decisions or life decisions based on that, right? So we thought that having a standardized pricing is very, very important for this, and it's familiar too, right?
Well, because I feel like this protocol compared to all the other ones is just about the usability. It's just about an ease of
cloud parity.
It's crazy.
Yeah.
It's crazy.
Yeah, we're going for cloud parity.
So we ditched the marketplace model. We can confidently say right now that 1 terabyte a month is $15. And I also know that 1 terabyte is duplicated 3 times on this network. Why are we duplicating everyone's data 3 times?
Yeah, it's a good question.
Why would we do that?
So when you build a trustless environment like this, where you have a bunch of untrusted parties, and if one of them pulls a plug on their storage provider, we need there to be 3 times redundancy, so the protocol has the opportunity to auto heal and give it to a new provider and then reheal that deal, so we can always bounce back in the event that a storage provider unplugs.
That point is really, really important for enterprises.
And that's what they don't understand. That's a big thing with our pricing too, right?
When I first came on board at Jackal, I was making cold calls to pitch people ideas about the product. It was a wild time.
200 cold calls, baby.
I was making hundreds of cold calls a day to try and get somebody to sit down with me and listen to an idea
about blockchains,
which was not. I didn't have the highest close rate there, to be frank. But I remember we almost stumbled our way into a sale. Before we had anything that we could sell people, we almost stumbled our way into a sale because I called a law firm and I spoke with the chief information security officer.
He was so rude too.
He was not, yeah.
He was so rude.
Regardless. Yeah, he was one of those guys, you got 5 minutes on the clock, go. My first question was, what do I have to do to earn another 5 minutes? He didn't, swing and a miss. But regardless, the only reason I got him on the phone was because he said to me, it's interesting you're calling me right now. My data center just caught on fire. All of my data is gone.
Like literally, like this isn't a joke.
All
like
gone.
He's dead serious.
Gone.
Yeah, you called me. I was
There's no
on
backup.
vacation.
That was the backup. Everything is absolutely 100% gone. And it's not like the law firm is
a small law firm.
But it's also not like they're storing unimportant data. It's not like they're storing like receipts for when Buddy went out for dinner the other day. Like they're storing evidence. They're storing really, really fundamental, mission critical things.
And they legally have to store for like they have 7 years or 50 years or something like that. They have rules and regulations around how long they have to keep it.
Imagine I hired a lawyer to represent me in court. I shared all of the data with my lawyer that's pertinent to the case, that's relevant to the case.
And they lose it all.
A data center catches on fire. So we stumbled our way into that, I think on like week 2. And it was a really eye-opening moment for me as somebody who was new to the protocol at that time of the importance of having redundancy, because it's not something that, it's not something that this chief information security officer, he's hired to think about these things. He didn't think about it until the data center caught on fire. It's not going to happen to me. Why would it happen to me? But of course it does. And that's the need for just a higher digital the privacy and cybersecurity posture in general. That's one of the ways that it materializes in our redundancy and geo-distribution. Yeah,
like it's an awesome feature of like the auto-healing nature of it, right? It's no matter what happens, the protocol is going to have that. It's going to have your data. It's going to if a data center catches on fire, that's only one version of the file, and by the time that they try to reclaim that, imagine like they miraculously put out the fire, turn the power back on, that file is already off their system, right? So like that file got moved to a new provider, so we can maintain the service level agreement that's built directly into the protocol that we will have 3x redundancy always, right? So it's very, very important, very, very special that we have that feature, because that's like the killer feature for a lot of the Web2 businesses. It's not like we've talked about this, it's not this privacy or ownership or anything like that. It's like
not having human beings in charge of things.
It's like the multi-region geo-distributed data storage that's auto-healing and verifiable. Like that is like, they just love it.
The way that I look at that feature in general is what it contributes to, whether we want to go feature, whether we want to go benefit, whether we want to just like zoom all the way out. Is we're offering this chief information security officer and others like him the ability to sleep at night.
Yeah.
That's what it is, right? You don't have to worry about this anymore.
And you don't have to pay somebody to worry about it for you either.
And I'm excited for Jackal Quick Connect for that use case, because like if we hand that to Jado, he's going to go gangbusters on that thing. But
so it seems like, okay, so for everyone, I feel like we touched on it. I'm just going to say it out loud for the audience. But any data that you upload to the Jackal protocol is automatically duplicated 3 times, and
triplicated.
And if anything should happen to even one of those copies, just like a storage provider goes down, they unplug their rig, the other 2 copies will step in. The protocol will be like, oh, there's not a third, and it will just make a third, and it will automatically do all this under the hood. So this is not only just like a security redundancy thing. I feel like it's also just an automatic thing, so you don't have to I feel like your data lives on the protocol, not with the storage providers. And it sounds like with Filecoin, I'm negotiating with a storage provider.
Yes,
and my data is living peer-to-peer with the storage provider.
It's directly peer to peer. Like in Jackal, you're dealing with the protocol, and the protocol takes care of you.
And that's why the protocol has one pricing structure.
Yeah.
Your data lives on I feel like it's this almost like ethereal layer above all this physical hardware.
It's like this data fabric or backbone or whatever it might be. But this is gonna sound like really like infomercially. He's like bye. But the side of things where it's really interesting is specifically the fact that you're paying. When we say like how much does it cost for storage, we say a terabyte's about 20. What is it right now?
On the protocol?
$15 a month.
It's
$15 a month per terabyte at the protocol level, right? That is not for 1 terabyte. That is for 3 terabytes.
3 terabytes.
Right? You're not paying ingress and egress across like the different nodes of the storage network. So you have 3 terabytes. You have no ingress and egress fees on that. And then on top of that, the third thing is it's auto healing and verifiable, right? So you're actually getting 3 terabytes that have like this like healing superpower at the same time, which it's really hard for us to communicate that. And I don't think we get that across very easily or very well. Where like people are like, oh, like $15 a month, that's expensive. Yeah. It's just like, dude,
Dropbox is like 10.
Yeah. Just dude, AWS is like 23 plus, but like for that build in like an AWS environment, you're looking like north of $150 a month. Like $150 a month, maybe even north of that. If you want like a data center in Asia that's holding it, or if you want it to be closer to some of your users, like it's like very, very, very expensive in Web2 land to do what we do. And we're offering it still cheaper. Right. So it's pretty special stuff. And we need to, you guys have to tell your friends about that.
You're basically saying that it's more than just the commodity that is storage that is included in the $15 a month.
It's all the like operations included in that.
Yeah. Right? It's just like all these automations and like protocol level automations and operations that are occurring that are just behind the scenes, very hard to communicate, but it's like cracked. When it comes to like the the distribution, like geo distribution of the data and the auto healing.
I'm just gonna sound super salesy, but it's a solution that we're selling on top of just the storage.
We're selling a solution,
right? And I guess and let's just talk about that solution compared to like Filecoin, for instance. If I'm uploading a terabyte of data to Filecoin, I'm negotiating with an individual.
It's me and you. Like it's me and you and a marketplace in the middle.
And they're gonna store one copy of that data, and I don't trust a hard drive to save my life, even if it was here or if it's like someplace else. So I have to manually negotiate a different copy of that data with probably a different storage provider, because why would I keep two copies with the same guy? No, that doesn't make any sense.
If you want to store a terabyte and you want like the same functionality on like a Filecoin or another marketplace style protocol, you're like having to negotiate with 3 other providers, right? And manage all those deals individually and go and check that those deals are being fulfilled.
And you need a node yourself.
And you need a node to send it to us.
I also feel like just in not only in case like a storage provider like goes down, but I feel like this helps your files just like continue in perpetuity just because like, I don't know, storage, there'll be some old server with some old drives at some point. That whole thing is going to like die or just not really be worth it. Someone's going to spin up a new one.
It happens.
So like if you're storing your file on Jackal and you pay for the full 200-year storage or a bajillion year or whatever it is, like in the future your file is going to be on some computer we've never heard of yet.
Yes.
Like ideally.
Yeah, like hopefully in 200 years, like that machine that it's going to be on, nobody's even thought of it existing yet.
It probably hasn't even been made yet. So like you're buying storage deals into the future to be stored on machines that don't exist right now on the network likely. Right, which is pretty crazy to think about.
Yeah. It really is. I like the idea of your file living on just the ethereal, like
it's the the data fabric of Jackal.
Your file's surviving you.
Yeah,
something you can give to your grandkids.
Yeah. Here, your file
private keys.
Your file can like our entire team can get hit by a bus, and your file will still be there, assuming there's validators running.
Yeah. We get that question all the time, though.
So here's the next thing I want to talk about, and I feel like Jaden already went on a tear on this, but we really didn't define it. But Filecoin has storage. Arweave has storage. To my knowledge, though, if you want to build a complex dApp, you need to build it on the Filecoin network. I know the Filecoin virtual machine is like a thing. Do we want people to come build on the Jackal network? Every layer one just wants developers to build on their thing and make their token go up. It's like it's literally every single one. I feel like
I think that one of the biggest competitive advantages that we have is actually the way that we do distribution. So Jackal, we actually don't want you to build on Jackal, like directly on Jackal, like come to the Jackal protocol and like launch an app. What we want to do, and the reason being is that you don't want, like, there's enough L1s that are viciously competing with each other in a zero-sum game for like 28,000 developers that exist. We don't want to do that too, right? So like you have the situation where what we are able to do is we're wrapping all of our protocol modules into a smart contract, and we're forward deploying that on every general purpose L1 that has developers on it. Right, so we want you to be able to use Jackal from Base. We want you to be able to use Jackal from Archway. We want you to be able to use Jackal from Solana. So by forward deploying all this, where you can make a call to our smart contract, it sends messages to the Jackal chain and back, where you're able to get that storage functionality without it being like a storage chain. We think that is awesome, and I think that our distribution advantage is really, really intense here, and this is our biggest edge, where we're just going to have every single chain is going to have data storage functionality. Hopefully, fingers crossed, before the end of this year.
So you're saying that, like,
right, Merson?
Yeah.
So any other blockchain
Yeah.
can come and, in theory, buy Jackal storage or like tap into Jackal storage. Like, developers do not have to build on Jackal; they can build anywhere. They can just link in.
Yeah, we're looking to destroy the concept of like a monolithic storage L1. We like the fact that you have to choose between having storage functionality and having like liquidity and community and like better good tech.
Wild.
Is just like oh, you can have like one of two. To build a web scale application that is competitive and like at parity with like Web 2 type products, you need both.
Yeah.
Right. So you can't just be like, oh, like I have like, that's why all the apps right now, they don't do a lot of like really intense things. Like it's just like marketplaces or lending or NFTs. Not that those are bad, or like even social, like it's kind of faking it. It's like 1 foot in, 1 foot out.
Well, even NFTs, right? Like we look at NFTs and, you know, the token is on chain and it's great and everything, but the actual like image metadata, or if it's a video, whatever, any of the actual file data that's going up, that was uploaded off chain, because even if it is using something like Arweave, it wasn't done, like you didn't upload your monkey pictures to Ethereum's NFT layer from Ethereum. You hopped off and then you copy and pasted everything. And that gap of needing things off chain and on chain, I mean, that's where we step in and fill that gap, where the second you launch your NFT platform or your NFT project or whatever else you need storage for, it can all be done on the network that you choose to do it all in one go.
That's what makes this beautiful, because people like, it's kind of hard to explain why do you need to why can't you just use an API? Like, we have APIs for like enterprise businesses and people that don't really need to have it on chain. But why do we need it on chain? Why do I need to use storage on chain? Why does it matter? I don't really care about decentralization. It's not really like a feature that I give a shit about. So like, why? Think about it just from a user experience perspective, right? If I'm going to launch an NFT, let's use an NFT platform because everyone's remotely familiar with this. I'm going to build an NFT collection. It says, okay, step 1, name your collection. I say, okay, like Patrick's NFT collection, right? Step 2, leave my platform, go find like an IPFS pinning solution. Go there, give them your credit card, store the files, get all the CIDs, and then come back. It's just like, oh, like what a boner killer, dude! Like,
I feel like it doesn't make any sense.
It's just not a good user experience, and because of the way that these things are built on chain, they need storage that interacts and is built for chain, right? And it solves a lot of UX issues like that. And if they choose to not do that, like they have to like do like the API things in the background, and also have like it's like spaghetti, like right? You're doing like it's more beautiful and it's more elegant and it's a better user experience if you do it on chain directly, and the user can pay for it, or you can build it into your economics that just pays for the storage directly. The automation abilities that you have with this is very, very special. So like that's why it's important outside of just like the decentralization or just like on chain. You know what I mean?
Well, and I feel like this right here, like the Web3 ethos, like keeping everything on chain, keeping everything like truly in this like no man's land, like this is where we started from. Like this is like we need the evidence to go in to this like completely neutral type environment. And right now every other blockchain is just buying Amazon storage and just kind of linking it to an NFT.
Yeah.
And
well, it's the same thing. You look at even like the whole AI agent meta that's happening right now, where everyone's building these AI agents. Those AI agents aren't on chain, right? The AI agents have wallets and they interact with the chain. Right.
Oh.
So if you don't sell, if you can, like, they can't buy storage because they don't have a credit card. So like all their memory right now, all that stuff is all purchased like by the developer, and they just plug in S3 like credentials into it. You have two options. Like for even us approaching that market, you can, number one, if you want S3, we'll give you S3. If the dev wants to take care of it, the dev can take care of it. That's cool. Here, change your S3 credentials, slap on Jackal through Quick Connect, happy. The other option is AI agent has wallet and tokens. They can buy storage, right?
Which is wild to think about.
Wild.
That an AI can buy storage.
That's wild, right? So you have like this ability where having the ability to buy storage, manage storage, delete files, do all that stuff at the chain level. If like for this industry to work, we have to do that stuff on chain. Right? Like if we want to build bigger, if we want to build web scale applications, like we need to have this functionality on chain locally on every chain. And we have like that's what we're looking to deliver specifically with the Outpost. And obviously we have Quick Connect and Jackal Pin for enterprises, and we have other stuff that's coming down the pipeline.
So let's dive into each of these. So we've obviously been talking about the protocol, why we built the protocol the way that we did. Now we need data on it, right?
Yeah.
And earlier we were kind of talking about how Storj built a really cool decentralized data storage protocol, but the on-off ramp was like a centralized sort of entity, which some people are fine with, and that's kind of great. But let's explore the different ways to actually put Jackal on, or not Jackal, actually put data on the Jackal protocol. Because I feel like there's some really special things that we do here that nobody else does. So let's start with the obvious one. Let's talk about Jackal Quick Connect, because I feel like this is probably the one that other developers are going to be like familiar with. And I feel like if you're a developer and you know what like an S3 API, Marston can fill you in. I feel like you can probably like link all those dots in. But Marston, what is Jackal Quick Connect for the developers? You can go into developer speak.
All right.
I think that's what.
The high level, it is a system that we have set up, and it is kind of a centralized gateway into the Jackal protocol. And essentially, it mimics Amazon's S3 storage system very, very closely. So you can use existing tech stacks that rely on the formatting that comes from Amazon S3 and use Jackal in its place. So it's basically a wrapper around the Jackal protocol that slots us into existing platforms that rely on AWS or Wasabi or even Storj.
Yeah,
which is pretty cool. And again, you can also pay for it with existing payment methods like
like
credit card. Which is pretty cool.
Yeah, so like Jackal Quick Connect is primarily for enterprises or developers that like need S3 type structuring around their data. And the ability to deliver that's really important. Like if the pitch, like without Jackal Quick Connect, if Jaden's going and approaching like a traditional enterprise, before Quick Connect, it's just like, hey, you can like run twice as fast and jump twice as high, but we're gonna have to do a spinal transplant. Is that cool?
Yeah.
And then, but with Jackal Quick,
tough sell.
Yeah, but with Jackal Quick Connect, it's very simple. It's just, hey, you know those credentials on your S3? And they're like, yes. It's like, okay, just like change them to these ones, and they're just like, oh, that's it. That's it.
So Quick Connect's just a way for us to slip into the back end of existing products that are using like traditional.
Very careful there, but yes, it's Jackal Quick Connect is a way for us to hack distribution, and hack interoperability for like traditional enterprises or developers, even in Web3. Some of them use S3 and have that ability to simply swap in place for that without too much of a headache.
I would argue that, you know, you said some developers in blockchain land use S3.
All developers.
I would make the argument to say that if you need a lot of storage, your only option is to use a centralized S3 bucket.
And Quick Connect too is like, that's not just for Web3 devs. This is just for
this is for anyone.
Anybody.
It's for literally the TAM of people that use S3. So like our total addressable market is anyone that uses S3 buckets. With that,
I back bringing TAM into this conversation.
Yeah, like it's pretty large. They do. There's a lot of S3 users out there,
and there's a lot of existing like tooling to go with S3. Like even something as simple as like we've talked about how complicated like an application like Vault is. Obviously, we had to rebuild that from scratch to work with Jackal. There are applications that are full front ends that let you just browse through your files already built for S3. And once that that already exists. So once you have your Quick Connect credentials, you just plug them into that and you just get to use that app straight up.
Or even just like the libraries, like the different libraries that you would have for Quick Connect.
For developer tooling,
like Golang libraries, Python libraries, like on
and
S3.
We don't have to build any of that at all now, and you can just already use those systems.
It's a pretty big hack for us to just like piggyback on that system and just like hammer that market.
Where are we at with Quick Connect now? Is that a fully available product or like?
It's still in development right now, but it's pretty close.
It's pretty close. Hopefully, like we need it like now.
When? 1 month, 2 months, 3 months?
Well, we can talk about
make a promise right
Do
now.
one.
Whoa!
This first 3 months of this year.
Whoa, that's soon. Yes. All right. So Quick Connect sounds cool. That sounds great for selling to some traditionalists, I guess. let's talk about the Jackal Outpost, which I feel like is
before we move on from Quick Connect, I'd just like to ask the fellas one question. I think it might be useful to whether summarize or to just kind of zoom out a little bit. If I'm using something else, let's say an S3 bucket, instead of Quick Connect, in your minds, Patrick, in your minds, Marston, why am I switching? What is the difference maker that we can offer with Quick Connect that they're not getting already with, let's say, I'm building
AWS or Wasabi.
Exactly right.
Yeah. My big thing is it comes back down to the auto healing and multi-region geo-distribution. That's pretty huge. I think that is obviously like the big ones for the enterprises just out the gate, and we're familiar with that. The other thing is like the saving on egress and ingress and transfer costs. That's a big thing that we're going to have the ability for them to save on to an extent, obviously, like if they like absolutely abuse it, since Quick Connect has like a middleware piece, because it's like we have to wrap S3. They can't like abuse it like crazy, but like to an extent, like it's pretty much free on that front because it's just built into the protocol economics. The last thing is, and I think that this is probably one of the most underrated and things that are a little bit more like not like a direct feature, but I think that Jackal Quick Connect is special because it gives businesses or people that are unfamiliar with blockchains a way that they can express belief in a technology like this without having to like gamble on meme coins or like buy coins, right? Like it's a way for them to express an opinion on this technology without doing things that they don't understand. It's something that they understand. It's powered by this technology, and they can express an opinion based on that technology. And I think that right now we're starting to see like larger businesses start to have like Web3 departments or blockchain departments that are trying to like use this stuff. Same thing with AI, where people are getting hired for like AI like roles at companies. I think that will continue as like this industry continues to grow, and I think that this is a great way for them to express an opinion on this technology as well.
Oh yeah, and because it's an actual thing, an actual product.
Yeah,
that actually works.
Whoa, that's crazy.
Crazy in Web3
in Web3. What?
But that might have been a little bit hardcore, but like that's how I feel about like having the ability to express on this technology an opinion by an action without just like taking your company's money and just like buying like, things that you're not familiar with. I think it's pretty special.
Well, it's also something that, not only just like, like expressing your opinion and stuff, like you can get actual value of it. There's like a good, there's like some new features that AWS doesn't have. There's like a reason to switch over.
Features, there's value, like there's actual value propositions that we're delivering to them. And then I think that's just like one's like also like an ethos product where like it's just like, hey, like you get to use this technology finally.
I feel like the marketing guy in me wants to just throw a little, what's like the CTA? If there's an entity out there right now that's
Jaden, this is a Jaden job.
Jaden.
That would be me. I would give you my cell phone number on the air right now.
You have to look directly into the camera.
But yeah, please reach out. Whether it be through the website, you can kind of fill out a form or get in touch with us that way, or you want to use the website which is jackalprotocol.com, to find us on Discord or find us on Telegram. I'm pretty easily accessible and would be happy to have a conversation.
Oh yeah.
Hell yeah.
Hell yeah.
Hell yeah, brother. Good CTA.
All right, going down the Jackal Protocol connections. First off, I'm going to pause right here. This is not recording. How's everybody doing? Everyone doing good?
Yeah.
All right. Take a break.
Yo, it's like I was thinking we pick up food.